What's going on, Algebros? It's Mr. C here to talk about the change of base formula. This is courtesy of page 4 of the section 6.5 note packet. And as you saw during the notes for this section, we were working with logarithms that had a variety of bases. We worked with a log of base 4. We also worked with a log of base 6. And from an algebra standpoint, we have an idea of how to work with those types of logarithms, but there's going to come a point where we need to type these types of logarithms into the graphing calculator. And unfortunately, with most models of the graphing calculator, you're not able to type in something like the log base 6 directly as it's written. But fortunately, there is what's called the change of base formula, which will allow us to work with any base of our choosing, which means that, for purposes of typing things into the calculator, if we wanted to change a log to a base 10 or a base e, this will allow us to do that. Alright, so let's assume, kind of in a generic way, that we have a log expression here, log base a of b. Alright, so the base of the log is a and the argument is assumed to be b. If we don't want to work with base a, but rather say like a different base, let's call it c, we're allowed to do so provided we write something out in the following format. Let's write log base c over log base c, and we're going to fill out these two arguments. The argument of the log on top is going to be the original argument of the log expression b, whereas the argument on bottom is going to be the original base of the logarithm. So if we wanted to change the base to something different, let's generically call it c for right now, we can rewrite log base a of b as log base c of the original argument, b, provided we divide it by log base c, and in that argument is the original base. Alright, so I know this is very generic and somewhat vague sounding, so I'm going to give you some of the most common change of base formulas, and those would involve base 10 and base e. So one common version of the change of base formula to use involves the base 10, or common log. So I'm going to rewrite log base a of b using this format, but with the base c equal to 10. And that would look like log of the original argument b divided by log of the original base a. Alright, so this is the common log version of the change of base formula. You can also do a natural log version, and I'll provide that for you here. You could do the natural log of the original argument b over natural log of the original base a. Alright, so these are the ones that we typically use. From a practical standpoint, we use these ones more often than other change of base formulas because these logs have buttons on the graphing calculator. Alright, so with that, I'd like to go ahead and show you how you can rewrite both these two examples using a change of base formula. And I'll leave it up to you to type them in, but I will provide you the decimal approximation to each of these once we've rewritten them in the change of base format. So the first one is log base 3 of 17. So from a concept standpoint, you're trying to figure out what power of 3 gives you 17. And that's not readily available. If you think about the powers of 3, 3 to the first is 3, then 3 squared is 9, and 3 cubed is 27. We don't really hit 17 with integer powers of 3. But that's really neither here nor there. I'm going to show you how to rewrite this using the change of base formula, and to let you know which version of these two to use is purely up to you. Surprisingly, if you use the base 10 version of the change of base, it winds up giving you the same exact decimal as the natural log version of the change of base formula. So I'm just going to arbitrarily choose the base 10 version. If you want to rewrite this using the change of base formula, you're going to do log of the original argument, which is 17, and then divide that by log of the original base, which is 3. And typing that into your graphing calculator, you should get roughly 2.58. Now I challenge you to do this a different way, this time using natural log of 17 divided by natural log of 3. And what you should see happening is that you would get the same value of 2.58. For problem number 2, I'm going to mix it up a little bit. I'm going to use the natural log version of the change of base formula, just arbitrarily choosing that one. And how you would do it is natural log of the original argument 8 and divided by natural log of the original base 1.5. And this should come out to be roughly 5.13. Alright, if you do this example using the base 10 version of the change of base, you'll get the same darn value. Alright, and that's all there is that you need to know about the change of base formula. Let me know if you have any questions. Otherwise, thank you for watching.